So in the previous video, we have shown that the series sine n over n squared, n from 1 to infinity, is absolutely convergent using a previously stated theorem. Next, we present another test for absolute convergence, and that is a ratio test. So the assumption before using ratio test is this one. So let summation an be a series of non-zero terms. So yun yung ating assumption. Yung ratio test, sinasabi niya ay two things. Number one, if the limit of the ratio ng a sub n plus 1 over a sub n absolute value as n goes to infinity is equal to some real number L, and L is less than 1, then the series is absolutely convergent. On the other hand, if L is greater than 1, or if the limit is plus infinity, then the series is divergent. So ito lang yung sinasabi nung ratio test natin, dalawang bagay. Depende dun sa makukuha ninyong limit ng ratio ng consecutive terms, absolute value. Before illustrating ratio test sa examples, meron tayo ditong warning, important warning, na if yung limit na makuha ninyo ay equal to 1, then yung ratio test is inconclusive. In this case, pwede kayong gumamit ng ibang test to determine convergence or divergence ng series. Okay? So, ito yung kailangan nating makuha, yung limit as n goes to infinity ng ratio a sub n plus 1 over a sub n absolute value. Okay. So, let's consider example 2. Determine whether this series is convergent or divergent. So as you can see, observe natin, no? Yung terms ng ating series ay alternating. Another observation is that meron ka ditong n factorial. And kapag may mga factorial, most of the time, or magandang unang subukan na gamiting test ay ang ratio test. No? Bakit? Makikita natin mamaya na nasisimplify lang kasi siya. So, yun. Tignan ninyo yung expression ng a sub n, tapos yun yung magiging basis ninyo kung anong test yung unang susubukan, or pangalawang susubukan, or pangatlo. So, dito, subukan natin ang ratio test. So, first, identify natin yung a sub n, expression for a sub n, pero ito lang yun, yung nasa loob ng summation. Next, kunin na natin yung limit ng ratio ng consecutive terms, absolute value. So, huwag kalimutan ang absolute value. Okay? Ang a sub n plus 1, makukuha nyo lang siya sa a sub n by replacing all n by n plus 1. So, halimbawa dito, ang a sub n plus 1 ay equal lang sa minus 1, replace n by n plus 1, replace n by n plus 1 over replace n by n plus 1, factorial nasa labas. Okay. So, yung expression natin para dun sa limit ay ito siya. So, a sub n plus 1 over or times reciprocal ng a sub n. So, kopyahin lang, baliktad. Before taking the limit, pwede natin muna siyang i-simplify. Itong 2 to the n plus 1, pareho lang yan sa 2 to the n times 2. Itong n plus 1 factorial, pareho lang siya sa n plus 1 times n factorial. Mas malinaw na makikita natin ang n factorial makakancel dito. Itong 2 to the n makakancel sa baba. Actually, ito din, minus 1 to the n, makakancel din ng minus 1 to the n dito. May matitirang isang negative 1. Pero tandaan, meron tayong absolute value. So, mawawala din yung negative. No? Ang matitira sa numerator ay, ayun, natira yung isang 2. Sa denominator, may natira tayong n plus 1. Okay. So, ang expression natin ngayon ay limit ng 2 over n plus 1 as n goes to infinity. And syempre, yung limit ay equal to 0. So, yung limit nag-exist, compare natin with 1. Syempre yan ay less than 1. So by ratio test, the series is absolutely convergent. Ayun. So, yun lang, no? Ito lang yung kailangan nating malaman and hope na yung limit ay not 1 para mag-work series sa test. Otherwise, use a different test. Okay. Next example. Okay. Wait. So, determine whether the series is convergent or divergent. So, observe muna natin yung terms ng series. Itong numerator, ibig sabihin nito ay product ng mga odd numbers, no, hanggang 2n minus 1, depende kung ano yung n, over n factorial. So again, may factorial, so mukhang okay ulit si ratio test, unang subukan. Ano bang ibig sabihin nito? Ang first few terms ng series natin ay, so when n ay 1, yung last factor dito ay 1, no? So meron kang 1 over 1 factorial, first term, plus when n is 2, yung last factor ay 3. So, meron akong 1 times 3 numerator over n factorial, 2 factorial. Kapag n ay 3, yung last factor ay 5. So, meron tayong product ng 1 times 3 times 5 sa numerator over n factorial, 3 factorial, plus and so on. So, product ng odd numbers hanggang dun sa 2n minus 1. No? Depende kung ano yung n. Okay. So, let's use ratio test to determine convergence or divergence of this series. So, first, malinaw, ito yung ating a sub n. Next, kunin natin ang limit ng ratio ng consecutive terms a sub n plus 1 over a sub n, absolute value. Pero in this case, yung absolute value pwedeng tanggalin kasi positive yung expression. So makikita ninyo itong first factor, ito si a sub n plus 1. Meron kang 1 times 3 times 5, yung first 3 factors. Tapos yung last, palitan nyo lang yung n by n plus 1. Sinulat lang din dito yung factor before yung last, no, which is 2n minus 1. So, denominator, replace n by n plus 1. So, meron tayong n plus 1 factorial. So, times 1 over a sub n. Okay, so ganun ulit. Before natin kunin yung limit, simplify muna natin yung expression. Actually, ito, magiging 2n plus 1. Tama naman, no? Kasi ito yung odd number after 2n minus 1. Itong nasa ilalim ay n plus 1 times n factorial. Okay. So, makikita natin ito, cancels n factorial. Itong lahat, makakancel ng nasa denominator. Parang yun lang, no? So, ang natira sa numerator ay 2n plus 1 sa denominator, n plus 1. Tignan natin. Ayun. Next, as n goes to infinity, ano ang limit ng expression? Makikita natin dapat ang limit ay 2, no? So, an intermediate step, ito siya. So, times 1 over n over 1 over n. Yung expressions na 1 over n goes to 0 as n goes to infinity. So, ang matitira ay 2. Limit nag-exist, so compare natin sa 1. Siyempre, ang 2 ay greater than 1. So, by ratio test, the series is divergent. Ayun. Okay, next, another example. So, determine whether this series is convergent or divergent. Meron ulit siyang factorial. Try natin ang ratio test. Okay. A sub n, ano ang a sub n? Ito siya. Next, let's look at the limit as n goes to infinity ng absolute value, a sub n plus 1 over a sub n. Ang a sub n plus 1, again, palitan nyo lang yung n by n plus 1. Sa ilalim, ito yung n. Palitan lang siya by n plus 1. No? Tapos times 1 over a sub n, kopyahin lang galing doon. Before taking the limit, ano yung pwede nating masimplify dito? So, itong nasa first factor, si minus 4, pareho lang siya sa raised to, expand natin. N squared plus 2n plus 1. Sige, pwede natin isulat further para mas madaling makita na magka-cancel. Pwede ko siyang isulat in this way. Tapos itong nasa denominator niya, ano ba to? 2n plus 3. 2n plus 3 factorial na pwede nating isulat na 2n plus 3 times 2n plus 2 times 2n plus 1. Pwede na yan. Factorial. Okay. Para mas makita na ito, makakancel doon. Ito, makakancel na ito. So, ang natira sa atin ay absolute value minus 4 to the 2n plus 1 over yung product na 2n plus 3, 2n plus 2. Okay. Yung absolute value, pwede nyo na siyang i-consider. So, mawawala na yung negative. Okay. Tignan natin, anong next line? Ayun. So, taking into consideration si absolute value, ang numerator natin ay 4 to the 2n plus 1. Denominator yung product, no? 2n plus 2 over 2n plus 3. Now, ano kaya ang limit ng expression na ito as n goes to infinity? Yung form ay infinity over infinity. No? So, next, mag-a-apply tayo ng L'Hopital's rule. So, dito binigyan ng importance lang yung theorem na na-state before na to get yung limit ng expression na ito. Ang n kasi dyan ay 1, 2, 3, no, and so on. Pareho lang din siya sa pagkuha ng limit ng function na pag tinignan mo siya as continuous. So, pareho lang siya, replace lang si n by x. Sa next slide, ito yung makikita nating expression, naka-multiply lang yung denominator, yung expression sa denominator. Next. Okay. Okay. So, syempre yung form, pareho pa din. As x goes to infinity, yung form na indeterminate form ay infinity over infinity. So, we can use L'Hopital's rule. So, using L'Hopital's rule, the limit is equal to ano ang derivative ng numerator. So, ang derivative niyan ay 4 to the 2x plus 1, ln 4, times chain rule, times 2. Pakita natin. Ayan. Applying L'Hopital's rule, derivative of the numerator is 4 to the 2x plus 1, ln 4, times chain rule, so times 2. Denominator, tama naman, no? 8x plus 10. So what is the limit of this expression as x goes to infinity? Ganun pa din, no? Infinity over infinity. So try L'Hopital's rule one more time. We get this one. So 2 ln of 4 is constant. Nandyan lang siya. Ano ang derivative nung unang factor? So 4 to the 2x plus 1 ln 4 times 2. Kaya naging times 4 dito. Tapos squared yung ln 4. Denominator ay magiging 8. Tama, no? Now, ano ang limit as x goes to infinity? Pwede na, no? Ang limit ay equal to infinity. Okay. So, kung babalikan si ratio test, kapag yung limit na nakuha ay infinity, meron bang conclusion? Actually, meron. Ano ang conclusion? The series is divergent, no? By ratio test. Okay. So, yun lang si ratio test. Meron pa tayong isang test for absolute convergence sa next video.